Hello everyone, welcome to Chaudhary Data World channel. Today I am here with a new video in SQL series, that is partitioning in SQL. We'll be watching the details regarding partitioning in SQL and the types of partitioning available into the SQL. All these things we'll be watching into this particular video. So let's get started with the video. So first let me tell you the scope of this particular video. So the scope is basically I will be telling you the types of partitioning available in SQL, and after that we are having the physical partitioning, under which we are having another partitioning that are vertical and horizontal. I will be making aware that what all these things are, what is this logical partitioning is, and rest of the thing, that how the vertical partitioning is getting done, how the horizontal partitioning is done, I will be explaining you into the separate videos. So let's go ahead with the types of partitioning in SQL. So the first type is logical partitioning, which you might be aware of. If not, then let me tell you that logical partitioning is nothing but the partition by clause, which is getting used with the Windows function. Windows function we have already covered up, into which we saw that there are several type of Windows functions like row number, rank, dense rank, next, previous. All these are Windows function, and what Windows function are, you can check out that video if you want to be in detail. So along with the window function, that is the row number or the rank or any window function, along with that we are using partition by clause, which is basically a logical partitioning. So what this logical partitioning is, so whatever your query is resulting, correct? So those query are getting, it is getting you may say bifurcated, as it is getting bifurcated in group by. But it is different than group by, because this group by, what it does is it groups the thing and it is giving you an aggregate, correct? When you are applying any aggregate function, it is giving you the aggregate. But in this partition, the window will be formed, of course, because you are using the window function. So when whatever the window is getting formed, that is logically separated out with each of the other windows. So it might sound you some confusing a bit, but when I will tell you and I will show you the demonstration, you will get to know what it is and how it is. So let me take you to this another here, whatever we are having. So here I have just taken up an example of row number and the rank. So this row number is the window function, as you already know, and on top of that, what we were doing initially, we were just applying order by person ID or the age, whatever you want to have. On the basis of it, whatever you want to have, basically the windows bifurcated. So windows is getting created on the basis of person ID if only you are passing order by person ID. Now this time what it is getting done, it will be partitioning by the age as well. What does it mean is, so if suppose if you are partitioning on the basis of age, then what it will do, it will first partition on the basis of person ID. That means it will first order by person ID, and then it will, whatever the query will be resulting, if that query will then be partitioned on the basis of age. So let me just show you the real demonstration in both of the scenarios. So suppose I am removing this particular one. I am removing this partition by age, suppose. Now this is what we already covered up, that select person ID, name, age, row number over order by ID, order by person ID as row number. This is simple window function we are applying. So what it is doing is, you can see over here, right, that row number has been applied on each of the row whatever we are having available over here. So there are 8 different rows, so 8 row number are getting applied. How? Because this is considering each of the person ID, since all the person ID are different. So in itself the each row is a window in itself, correct? So what we are doing is, we are now applying partition by age. Now what it will do, it will create window on the basis of age, and those A's will be partitioned by, that means it will be a window also. First it will create window on the basis of A's, then it will partition on the basis of A's. So let me just demonstrate it. So you can see the change in row number, correct? That means what it is doing now, it has partitioned on the basis of A's. That means 25 is into the separate partition. That means each of the partition, whatever it is there over there, whatever windows getting formed, those windows are in separate partition. That's it. So this is a logical partition. And why we use this logical partition even? So suppose in upcoming scenarios that you might be applying some you may say arithmetic operation on different windows, there should be different arithmetic operation. So those things, it's the advanced thing in which you can apply, you can have a multiple scenarios which can be covered up when your windows will be partitioned, your windows will be logically partitioned. So here you can see now, right, that row number, it has been taken up as 1 for this A is 25. These 30 and 30 both are in same window, or you may say the same partition. So it is 1 and 2. After that we are having 35. So it is also 1, because in this window it's only 1. So in every window it is starting up with 1. 40, 40, 40. So it is 1, 2, 3. Correct? After that 45, it's again 1. So this is how it is getting done. You can also apply rank over it. So if you will uncomment it, you will run it, you will get to know that rank is also, so it is telling comma, I have just missed it. Now if you will run it, you will get to know that this person ID, name, age, after that we are having row number, and then age rank. So in age rank as well, you can see that it is taking all the windows in separate partition. That's how the logical partitioning goes on. After that, another type of partitioning we are having is the physical partitioning. So in physical partitioning, what it does is the database process where very large data tables are divided into multiple smaller parts. So it will be done on physical basis. That means it will really be bifurcated or partitioned on the large data tables, whatever you are having, it will be bifurcated on the smaller parts. After that, we are having another point that reduce the overall response time to read the data for particle SQL operation. Of course, it will increase the performance. It will be there for you for increasing your performance. After that, there are types of physical partitioning again. Those are vertical partitioning and horizontal partitioning. The vertical partitioning is nothing but if suppose you are bifurcating some of the column, because into your data set, let's suppose a scenario. A scenario might be that if you are having a patient data table, or you may say patient table, into that patient table you will be having patient name, patient age, patient contact number, and at last patient report. This report might be into the PNG format or the JPG format, which will be the basically pictorial format. That pictorial format, definitely it will be the link over there. So each time when you will be querying the patient information, you need not to query the report, correct? You will only be 95% time, you may say that you will be querying your patient name or patient contact number, something like that. That means their information only you will be querying it on. So what you can do, you can just put those informative table that are name, age and email or the contact number, these things into a single partition, and the report that is into the link format, you may say, or the PNG format, that will be taken into the another table, which will be the another partition. So this is how we can divide both of the you may say this particular table into two separate partitions, which will increase your performance. How it will increase your performance? Definitely when now you will query any information or the detail from that particular table, it will not scan for the report column, because that report column will be into that separate table, correct? And if suppose some report will only be needed, then only report table will be queried, which will increase the performance, right? Another type of partitioning we are having is the horizontal partitioning. The horizontal partitioning is nothing but this. Suppose if you are having a date column into your table, correct? Now this date column, against each of the row there will be some particular date mentioned over there, right? So if suppose monthly wise whatever rows is over there into your table, if you want to separate it out into separate table, suppose for January there should be a separate table, for February there will be separate table, for March there will be separate table, for each of the month there will be separate tables. So there will be 12 separate table for 12 different months. So in that particular case, what you are doing, you are bifurcating the data, not the column. You are bifurcating the row, not the column, correct? So it's only called that horizontal partitioning, in which you are bifurcating, or in which you are pulling out, or in which you are partitioning on the basis of row. So this is how horizontal partitioning goes on, and this is how the vertical partitioning goes on. So this vertical partitioning and horizontal partitioning, this is a very wide concept which I will be covering up each of them in single video. So in upcoming videos I will be first covering up the vertical partitioning, then the horizontal partitioning. So stay tuned to the channel and see you in the next video with this vertical partitioning and horizontal partitioning. So thank you so much for watching this video out, and see you in the next one. Thanks again.